Lesson time, yes! Happy. Lesson time is here again. Module 6, Lesson 8, delving deeper into the world of decimals. Today's one of those ones that's kind of straightforward, but you really have to be alert to get it. And once you get it, you're like, okay, no problem, this makes sense, I got it. And I've been priming you for this lesson because I knew it was coming up. On the other hand, this is one that if you're not totally alert, aka paying attention, you're likely to get a little confuddled and it'll be more difficult to get back out of that hole. So don't fall into that hole to begin with. Keep alert here. This is what we're doing. We're going to use our understanding of fraction equivalence. Okay, we know that already. For example, 1/10 equals 10/100th. That's an example. To investigate decimal numbers on the place value chart expressed in different units. Okay, so you'll see what that looks like, but it's, for example, saying if you had 11/10, that would be 110/100ths, which makes sense. If you had 11 dimes, that would be 110 pennies. But we'll get to that. Let's start off with a little warm-up. You see you have a sprint here, so go ahead if you're going to do that and pause the video. Do side A, flip the record to side B, number correct, improvement, how much better you did in side B in the given amount of time, whatever that is. All right, here we go. This is just a quick review of yesterday's lesson, and in fact, we're going to do this in the simple expanded form, not the whole this times that plus this times that. So 4 is 4. It's 4, right? Okay, that's the value. What's the value of this 1? It's 10/100ths, although we could also call it 1/10, right? So we have 4 plus 1/10, and then what do we have? 7/100ths. So you see, even in fraction form, we're just going digit by digit and saying what place is it in, what's its value. Okay, now let's look at this one. A tendency here is to just say 25, but we know we need to go digit by digit. So the 2, its value is 20. The value of the 5 is 5. The 6 now, its value, yes, is 60/100ths, but simplified, that's 6/10ths. And the 4, its value is 4/100ths. Beauteous! Now this one, we're going to do the same thing, simple expanded form, but with decimals. So the 5, its value is 5, right? All right, the 9 is in the tenths place, so its value is 9/10ths. Isn't this easier in decimal form to do that 9/10ths? Then you don't have to do the conversion there. And then the 3 is in the hundredths place, so its value is 3/100ths. Note the way it's written there. A 3 in the hundredths place. All right. Whoa, bigger number scary. No, okay. The value of the 2 is 200. Value of the 5 is 5. 7 is in the tenths place. Its value is 7/10ths. The 8 is in the hundredths place. Its value is 8/100ths. Beauteous! Now, here we go. Right into, I know, was that quick or what? Right into the application problem here. These boys got money! Jashawn, Alva, James, they got money. And look what this one cracks me up. I tell you, sometimes the Eureka math word problems are like as dull as dirt. There's like, container A can hold this and container B. This one is great. I love it. All right, it's like the chipmunks. Jashawn had 5 $100 bills. So that means a $100 bill. She's got 5, or he's got 5 of them, and 6 $10 bills in his wallet. Okay, Sean, you should not be walking around with that much cash unless you're going to buy yourself a couch or something. But we'll move on. Alva had 58 $10 bills under her mattress. No comment. James had 556 $1 bills in his piggy bank, and that has to be a pretty big piggy bank to fit that. They decide to combine their money to buy a computer. Hopefully they are siblings, otherwise there will be some complications there. But in any case, what's the total amount of money they have using the following bills? This is one of those important application problems where it's not just a review, but it really sets us up for what we're doing today. So watch this. We're going to figure out the total amount of money they have first, right? Put it all together. And then express it as, well, how many hundreds, tens, and ones would that number be? And this can be confusing because it's not how many hundreds, tens, and ones do they have. we already know that, right? All we'd have to do is a simple combination. But it's how many would they have in that amount of money. If you were to break down that amount of money into tens and ones, how many tens would it be, how many ones? And if you were to have it all in $1 bills, what would it be? Here's what that looks like. Okay, so Deshaun, he has $500 bills and 6 $10 bills, all right? How much is that all together? 500 plus 60 is 560. Alva digs under that mattress, pulls out her 58 $10 bills, and how much money is that? 58 times 10, we know times 10 slide, right? All right, so it's 580. Nice job, Alva. James, meanwhile, 556 $1 bills, well, that's just 556. When you add these up, 0 and 0 and 6 is 6. 6, 8, and 5. Well, I like to do the 6 and the 5 is 11, plus 8 is 19. Regroup the 1. 5, 5, 5 is 15, plus 1 is 16. So you end up with $1,696. Nice job, guys. You can actually get a MacBook. All right, so let's see, the $1,696. So we're going to take that and put it into how many hundreds, tens, and ones would that be? And again, the confusion might creep in here because you're looking back at what they actually have, but that's not what the question is. Okay, so if you look at hundreds, you look at, I keep making that menu appear. Go away. Go. Okay. 16, all right, I'm just going to let the menu be there. 16 in the hundreds place. How many hundreds would that be? It's 16 hundreds. Do you see why? Because if you only said 6, well, that's not it. You still have the 10 hundreds for the 1,000 there. Okay, so it's 16 hundreds. That's where I get 16 hundreds from. And then it gets easier from there. How many $10 bills would that be? 9 $10 bills. And how many $1 bills would that be? We see it's 6. Okay, great. This is a big setup for today's lesson, so watch this. Now look at the tens. I'm going to make the menu pop up again. All right, here's the tens place where the 9 is. Read this number out to the tens place. 169 is 169 tens. And this harkens back to Module 1 as well. 169 tens. So how many tens are there? 169. And then again, how many ones? 6. Great. Now, if we were to take that whole amount, $1,696, in $1 bills, James would certainly be happy, and you'd have quite an impressive stack of billage there. But how many ones would that be? Yes, 1,696. Okay, and so you see, look, 1696, 1696, 1696. Ah, it's just how you look at it. It's all the same amount of money. It's just how you look at it in terms of place value. And that is essentially what we're doing today. So we're going to take numbers in unit form, and we're going to then represent them in different units using an area model. What does that look like? It looks like this. Here we go. How many tenths are in one whole here? Well, there are 10 tenths, right? We see that, 10 tenths, okay. How many one wholes do we have here? Well, we have 2, 1, 2, shaded in completely. Then we have a fraction over here. How many tenths are in these 2 wholes? Well, there's 10 and 10, so a total of 20, right? How many tenths are over here? You count 4. Good. All right. So it's 2 ones, 4 tenths. How many tenths altogether? Think about that. All right. So how many tenths altogether? 10, 20, and 4 is 24. So it's 24 tenths. All right, got that? Again, related to money. If this were $2.40, this would be 24 dimes, 24 tenths. All right, how do we write that as a decimal? 2.4. Now, let's take this same area model and zingo, make it hundredths. So now how many hundredths are in a whole? Well, these aren't divvied up into hundredths, but you know there's 100 hundredths here and 100 hundredths here, right? So 2 wholes are 100 hundredths each for a grand total of 200 hundredths. Pennies, right? $1 is 100 pennies, $1 is 100 pennies, 200 pennies together. Now, what do we have going on over here? The 4 tenths, that same 4 tenths from the last area model we did. How many hundredths is that? Well, 10, 20, 30, 40. Ah, okay, so it's 240 hundredths. So how many hundredths altogether? 100, 140, total of 240 hundredths. Now think about it. Those are pennies, those are cents. Hundredths are cents, right? So how many pennies? 240 pennies would be $2.40. Do you see $2.40 as 240 pennies? Yes, you do. Great. So how do we write that as a decimal? Well, we'd write it the same exact way we did before, as 2.4. Now, if you say, whoa, 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 2.40, I'd say you are also correct. Great. So now we're going to do something similar, but we're going to use place value discs so you can see how this looks. So let's represent 2, the whole number 2, as tenths. So how many tenths are in 2 ones? Well, we just did this, remember, right? So 1 whole is 10 tenths. So 2 wholes is 20 tenths. 10 tenths and 10 tenths, 20 tenths. We just saw that in the area model, right? Now, here it is. 2 is 20 tenths. We see that? $2 is 20 dimes. Excellent. Now let's put it on a place value chart with, as promised, place value discs. So 2 ones, 4 tenths. Now if we were to decompose these 2 ones as tenths, in other words, if you cashed in your dollar bills for dimes, it'd be 10 dimes and 10 dimes, 20 dimes over here. Now how many dimes do we have? How many tenths? 24 tenths. This is the same number as the last 2 examples, right? Now, if you were to take, these 24 dimes and cash them in for pennies, why? I don't know, but let's just pretend you're feeling like it. So these 24 dimes, you say, hey, you go to the bank, the cray-cray bank, and say, hey, I have 24 dimes, will you give me pennies first? And they're like, sure, whatever you want. How many pennies would that be? 24 dimes is $2.40, 240 cents. Oh, it would be 240 hundredths. And yes, I'm not drawing 240 circles in here, not even on a computer. All right, so 240 pennies, 240 cents, 240 hundredths. Now, see that? This is key to this lesson here. 2.4, 2 and 4 tenths, can also be expressed as 24 tenths or 240 hundredths. Equals, equals, equals. There we go. 2.4 equals 2.40. 2 and 4 tenths equals 2 and 40 hundredths. Got it? All right. Now, now that you got that, let's see if you can do it in fractions. 2 and 4 tenths equals 24 tenths. You got it. And that would be equal to what in hundredths? 240 hundredths. 24 dimes, 240 pennies. We see the connection there? Great. Here's how we write as a decimal. The 2.4, although we could also, as we already said, write it as 2.40. 2 and 4 tenths, 2 and 40 hundredths. Excellent. Now, last thing here, I believe, we're going to decompose mixed numbers and express it as smaller units. So you know what a mixed number is, like we were just doing, 2 and 4 tenths. All right, so let's do this one. Read this. 3 and 6 tenths. All right, so how many tenths are in those 3 ones? Right, there are 30 tenths. $3 is 30 dimes, okay? How many tenths are in the whole thing? 3 and 6 tenths is 36 tenths. And I taught you this some lessons ago in anticipation of this, so you wouldn't get confused. See, read it as a number, ignore the decimal. 36, what place are we in? Tenths. Excellent. Now, let's write in unit form how many tenths are equal to 3 and 6 tenths. So 36 tenths equals fraction form, 36 tenths. How many hundredths now in 3 ones? Well, 1 is 100 hundredths, so 3 ones is 300 hundredths. Plus then we have the 6 tenths. Okay, so 6 tenths is 6 dimes, that's 60 cents, 60 hundredths. So 300 hundredths, 60 hundredths. Together make 360 hundredths. There it is. And notice, give you a little sneak preview again, if I were to place a 0 here, I would not be changing the value of 3 and 6 tenths, but I would read 360 hundredths. Okay, watch that, it's coming up. because now you have the problem set. All right, so if you look here, this is exactly what we're doing. You're working with 250 hundredths, and notice how many tenths is that? And then how many ones and tenths. Ones would be how many are filled in completely, and then to write it as a decimal, okay? And then how did you get your answer to part A? That explanation, I would say, can be pretty simple. It has to do with the relating tenths to hundredths. So I would say I looked at how many tenths there were, and then decompose that into ones and tenths. Just explain it in those terms. Not what I just said exactly, but in those terms. Now here you're going to do it with place value discs, and look how generous they are. You have no number larger than 3. That's quite a boon to you. So you have less little circles to draw. And now we're going to say 1 is how many tenths? Well, tell me, how many tenths? 10 tenths. So then let's look at, I'm going to skip B, look at C. 1 and 7 tenths is, read it as a number. 17, where are we? Tenths. Same thing here. 10 and 7 tenths, read it as a number. 107, where are we? Tenths, okay? And then you have now same thing, but in terms of hundredths. Okay, so start here again. 1 is 100 hundredths, okay? Now you can actually go ahead and draw a little 0 here to help you after that 7. I realize it's not true. Or you can rewrite the number on the side. 1.70. Read it as a number. 170, then what place will we be in? Hundredths. See how that works? Now here, you might get an answer that makes you say, that can't be right, but it is. Again, if you were to write that 0 there to take it out to hundredths place, you then have 10 and 70 hundredths. 1,070, what place am I in? Hundredths. You see how those work? And then you have those to do. And in the chart here, you're doing something very similar. You take the decimal. Now we'll look at this one, 2 and 1/10. Mixed number, 2 and 1/10. Same thing, okay. For this 21 tenths, look, 21, what place am I in? Tenths. Now for the 210 hundredths, if you write a 0 here, 210, what place am I in? Hundredths. Same thing with the rest of those in fraction form as well. Exit ticket, as always, same thing, but less of it. Decomposing there. And when you get to homework, you know what to do. Hustle your little self on over to homework time, and we'll go step by step through that together. Well, look what you and your marvelous self have done. You have completed yet another lesson time. Congratulations to you and your cat too. And I will see you again next time. It is once again a lesson time.